Hello everyone, welcome you to the next session on inverse trigonometric functions of class 12 mathematics. In this session, we'll solve the remaining problems from exercise 2.1. Here we have the 11th problem of the exercise. Find the values of the following. The 11th problem is tan inverse of 1 plus cos inverse of minus 1 by 2 plus sin inverse of minus 1 by 2. We need to find the value of all this. Now, we have discussed about finding these values separately. Like in the previous session, we had found the values like cos inverse of minus 1 by 2, cosecant inverse of minus root 2, all these. Now we have some operation. We have some expressions here with the trigonometric functions of their inverses. So we have inverse trigonometric functions with some operations and it's kind of an expression. So let's see how to solve it. Now we cannot solve this at a stretch. So what are we going to do here is we are going to consider every term separately. Like the first term is like tan inverse of 1. We are going to consider this as x. And the second term we are going to have it as y, and I'm going to solve separately for this. And the third term it's like sine inverse of minus 1 by 2. We can have this as some z. So we are going to have it like instead of all sum of all trigonometric inverses, we are going to have something like x plus y plus z. So if we find these values, it will be easy for us to find the value of the entire expression. Now let's see how to get these values one by one. The first thing, let us take the first term of the given expression, that is tan inverse of 1. Let x is equal to tan inverse of 1. This is not a new for us. We have already solved a few problems based on it. Like if we have y is equal to something like sine inverse of 1 by 2, we wrote it like sine y is equal to 1 by 2. In the place of y, now we are going to have x. So the procedure is same. We have x is equal to tan inverse of 1. So this means that tan x will be equal to 1. So we have tan x equal to 1, and we also know that tan pi by 4 takes the value 1. And if at all we check the principal value of tan x, principal value of inverse of tan x, we can understand that it is an open interval minus pi by 2 to pi by 2 is the principal value of inverse tan x. Hence, this pi by 4 is a value which is one among the open interval minus pi by 2 to plus pi by 2. So this is the principal value, and we have pi by 4 in between this. So we can take pi by 4, which is going to be the principal value here. So from these two, we understand that x is equal to pi by 4. So out of three terms, there is x, y and z. We got the value of x, which is nothing but pi by 4, or otherwise tan inverse of 1 is equal to pi by 4. Now let's try to get the value of cos inverse of minus 1 by 2. And as I said, I'm going to assume this cos inverse of minus 1 by 2 as y. So this gives us cos y is equal to minus 1 by 2. Now where do we have negative of cos? So this 1 by 2 can be like cos pi by 3, but we have minus 1 by 2 here. So minus of cos pi by 3 gives us minus 1 by 2. If at all we look at the principal value of cos inverse of cos, we know that it is nothing but closed interval 0, pi. Now we have minus of cos this, I have to bring this negative within this angle. So what I'm going to do here is I'm going to look for an angle which is between, or look for a value of cos which is lying between the 0 and pi. So we have a negative of minus 1 by 2 here. So this tells me that cos theta, that is the cos function, takes negative value. Now as we know, we have learnt in our previous classes, that is in our 11th standard, we know cos becomes positive in the second quadrant. When you consider 0 and pi, you have two quadrants here. One is the first quadrant and the values lying in the second quadrant. So these are the two quadrants in which cos values are lying between, out of which we have cos as negative here. So cos becomes negative in the second quadrant. So the pi by 3 can be written like pi minus pi by 3. So that gives us the negative value, that is minus of cos pi by 3 can be written as cos of pi minus pi by 3. I hope you will be able to understand all these concepts because we have already discussed enough problems similar to this in our 11th standard. So if you still want to have a clear idea, just take back your 11th textbook. You will have a better understanding on this. So we'll have cos of pi minus pi by 3 will give us minus 1 by 2. That is negative value, which is minus 1 by 2. But when I simplify this pi minus pi by 3, I get 2 pi by 3. This tells me that cos 2 pi by 3 will be equal to minus 1 by 2. Of course, this 2 pi by 3 is between 0 to pi. There is a closed interval 0 to pi. This is one of the values between these values. So this tells me that y is equal to 2 pi by 3, or cos inverse of minus 1 by 2 is equal to 2 pi by 3. So we are done with the second term of the given expression. Now the left out term is sine inverse of minus 1 by 2. Now as I've already told you, I'm going to give a letter z for this sine inverse of minus 1 by 2. So let z is equal to sine inverse of minus 1 by 2. This means that sine z is equal to minus 1 by 2. Now where do we have this negative value for sine? This 1 by 2 is nothing but 30 degrees. Sine 30 degrees gives us 1 by 2, but we have a negative value. So this means that minus sine of pi by 6 gives us minus 1 by 2. Now sine is negative in the it's a in first quadrant we have all this positive, and sine is negative in the third quadrant and also in the fourth quadrant. But what is our principal value? Our principal value of inverse of sine x is nothing but the closed interval minus pi by 2 to pi by 2. So this means that we have to get a value in between this closed interval. So when I consider minus pi by 6, that is sine of minus pi by 6, that will be definitely a value in between this closed interval. That is, I'll be able to see this minus pi by 6 lying between this minus pi by 2 and pi by 2. Hence, I can rewrite minus of sine pi by 6 as sine of minus pi by 6. Now there may be a question, why is that we won't be able to write this minus cos of pi by 3? Like can't we write like this, minus cos of pi by 3 as cos of minus pi by 3? No, this is not possible because this also we have learned it in our 11th standard. Cos of minus x is equal to plus cos x. So this I cannot use it. That is why I was looking for rewriting this angle, that is pi by 3, in terms of pi minus pi by 3. Now when it comes to sine, we have if at all we have sine of minus x, that can be written as minus sine x. So with this understanding, I am trying to write minus sine of pi by 6 is written as sine of minus pi by 6. Now this means that sine of minus pi by 6 is equal to minus 1 by 2. As I was telling you, this minus pi by 6 is one among the values between minus pi by 2 to pi by 2. So we are able to find a value which is between the principal interval, I could say, or the principal range. So this means that z is equal to minus pi by 6. That is, sine inverse of minus 1 by 2 is equal to minus pi by 6. So we have got all these values separately, that is tan inverse of 1, cos inverse of minus 1 by 2 and sine inverse of minus 1 by 2. Now let's see the operation between all these things. We have to add all this so that we'll be able to simplify it. So let us put all these values together. We'll be having it like tan inverse of 1 plus cos inverse of minus 1 by 2 plus sine inverse of minus 1 by 2 is nothing but, as we know, tan inverse of 1 is pi by 4. Here we have tan inverse of 1 is pi by 4. So the first thing is replaced by pi by 4, and the second one is cos inverse of minus 1 by 2. Cos inverse of minus 1 by 2 is 2 pi by 3. We have it here. So that has been replaced by 2 pi by 3 here. And the last one is sine inverse of minus 1 by 2. Sine inverse of minus 1 by 2 is minus pi by 6. So we have the last one as, instead of plus we have it as minus pi by 6. So we have done all the substitutions. Now the things that are left out is only the simplification, for which I have to find the LCM. So LCM of 4, 3 and 6 is nothing but 12. I can write it like this becomes 3 pi plus 4 into 2, that is 8 pi, minus 6 into 2. So here we have 2 pi, the whole divided by 12, which gives me 9 pi by 12, and that is simplified to 3 pi by 4. So this means that the given expression takes a value 3 pi by 4, that is tan inverse of 1 plus cos inverse of minus 1 by 2 plus sin inverse of minus 1 by 2 is equal to 3 pi by 4. So when you are seeing this expression, you would have thought it is a little complicated, but it is actually not such complicated one. Divide it into as many terms as possible. Use your knowledge of inverse trigonometric functions, their domains and ranges, and how to get the values, and then add all the subtract and substitute all the values and add it or subtract it. Simplify it so that you'll be getting the required value. So with the same idea, we are going to solve one more problem in the same exercise. That is, we have the 14th problem of the exercise here, which is nothing but tan inverse of root 3 minus secant inverse of minus 2 is equal to, you have 4 options here. One is pi, another one is minus pi by 3, third one is pi by 3, and the last one is 2 pi by 3. So this is a multiple choice question where we need to find its value. Though it is a multiple choice question, we need to work out and understand what is the solution for this. So as we have the previous problem, we have two terms here. That is, we have it like tan inverse of root 3 minus secant inverse of minus 2. So we have two terms here. Let me call the first term as x and the second term as y. So here we have the first term, that is, let x is equal to tan inverse root 3, that is tan x is equal to root 3. Now it is very obvious that tan pi by 3 gives us root 3. So we have x is pi by 3, or I can say tan inverse root 3 is equal to pi by 3. So the first part of the given expression is done. Let's move on to find secant inverse of minus 2, for which I am going to assume y as secant inverse of minus 2. So secant y is equal to 2. So this means that secant takes a negative value, that is, it becomes negative, and that is minus 2 here. We know secant is negative in the second quadrant. So instead of writing this, this is also similar. The properties of secant is almost similar to cos. So I can write, if you have secant of minus x or minus y, that can be written as secant y. So I cannot use a negative angle here. So let me see how am I going to rewrite this as. But I have secant y as negative 2, so that means that minus secant of pi by 3 gives the value minus 2. And let us see, let us try to know what is the principal value range for inverse secant. The principal value range of inverse secant is nothing but the closed interval 0 to pi, but you won't have the value pi by 2. It is all the values from the closed interval 0 comma pi except pi by 2. So we need to see whether we have this value here, for which I need to rewrite this angle pi by 3. So pi by 3 can be written in the second quadrant in the form of pi minus pi by 3. So if I am able to write pi minus pi by 3, it means that the trigonometric function will be lying in the second quadrant, and hence it takes the negative value also. So secant of pi minus pi by 3 is same as minus secant pi by 3. Now when I simplify the terms inside the bracket, I will get 2 pi by 3. That is, secant 2 pi by 3 will be equal to minus 2. This means that secant, we have secant y equal to minus 2, secant 2 pi by 3 equal to minus 2. This tells us that y equal to 2 pi by 3, or secant inverse of minus 2 is equal to 2 pi by 3. Now we had two terms to be found, and we have found the values of those two terms. Now let us try to simplify and find the final answer, for which I can just have a look at the question. It is nothing but tan inverse of root 3 minus secant inverse of minus 2. So these two have to be subtracted. So when I substitute the required values, I get tan inverse of root 3 minus secant inverse of minus 2 is equal to pi by 3 minus 2 pi by 3. When I simplify again, minus pi by 3. Now, let me just have a look at the options given to me. I could see minus pi by 3 here. This is option B. So, option B has minus pi by 3. Hence, this is the right option. So, tan inverse of root 3 minus secant inverse of minus 2 is equal to minus pi by 3. So, these two problems would have helped you to understand or to solve the inverse trigonometric functions, that is finding the principal value of the inverse trigonometric functions. From question number 11, you would have seen that the question was not actually find the principal value, but still we were using the principal value. So, unless until specified, we will always go for the principal values for the required trigonometric functions. So, whenever you are asked to find the values of any trigonometric functions or to evaluate all those things, always go for the principal values. Now, what do we have? So, we have almost covered almost all the problems of the same exercise. There are a few problems left out for you as homework, and here are they. This the question number 12 and 13 of the same exercise are going to be your homework. So, with this, we'll be completing this particular topic, and I'll meet you in the next session with the next topic of the same chapter. Thank you.